Yeah, so hi, I'm Lizzie. I'm the Medical Director at Aidence, and I'll be doing this session with Jeroen.
Yes, so my name is Jeroen. I am one of the co-founders of Aidence and the COO. And Lizzie has been working at Aidence as a medical director and closely involved with our lung cancer screening initiatives around Europe. What we will be talking about in this session is lung cancer screening, initially explaining what it is, why we're organizing this throughout the UK, and how AI can enable lung cancer screening programs.
Exactly. Okay, so I'm just going to give a little bit of background to explain why it's relevant. So lung cancer is the leading cause of cancer-related deaths worldwide. And a big reason for this is because lung cancer is often diagnosed at a late stage because symptoms don't present until later on. So there's been a lot of discussion over the last decade or so on initiating screening in asymptomatic at-risk individuals. So, and especially now that we've got the ability to do low-dose CT scans, which provides good quality images. I think one of the first national initiatives for a screening program was in the US, which started in 2014. And since then, there's been an increasing number of pilot studies going around in different countries, in the UK, in Europe, showing the efficacy of lung cancer screening to detect lung cancer early and therefore be able to treat it and improve survival rates. Recently, the Nelson study, which is well known, was published, and off the back of that, there's been quite a lot of push and recommendations from medical societies to actually introduce government-led, government-funded programs across countries in Europe and the UK. And actually last year, the NHS announced that they are rolling out this targeted lung health check pilot. So the idea is it's a multi-centre pilot study over 10 different sites in the UK. It'll last for 4 years. And it's a stepping stone to then go on to a national programme. So one of the things we wanted to discuss was, it's a huge decision for a country to decide to introduce a new screening programme.
There's going to be a lot of extra scans coming at the system.
Absolutely. Of course, for a screening programme to be successful, the benefits, of course, must outweigh the risks to the target population. So in this case, the benefits would be, well, can we detect the disease early enough that we can treat it and therefore improve survival rates? You obviously need a large workforce to be able to do that, and we all know the strain that the NHS is already under. In particular, there's the radiologist side of it, so the radiology shortage that is quite well known across the UK. So I think one of the big challenges is how will they cope with this huge increase in workload. So just for the first year of the target of the pilot programme, there's predicted to be 81,000 additional CT chest scans on top of their already heavy workload.
And the total volume I read last week is only like 566,000. So the new load is going to go crazy on basically additional on top of the current system, right?
Exactly, yeah.
So that's where AI comes in. So that's exactly what we've been working on. There's a shortage of radiologists, workload's increasing, so what we're looking for in these lung cancer screening programs or targeted health checks is something to save time for radiologists to read these scans. They need a means or a tool to reduce the reading and reporting time because for lung cancer screening, there's a specific requirement to report several findings. So it's not a normal CT chest scan that needs to be reported. And AI can actually help on that front. So what we've developed is an AI that automates both reading aspects as well as a tool to facilitate the reporting at a higher pace than you could do as a full manual process. So we brought together several scientists, key opinion leaders in the UK specifically, but also throughout Europe right now, to develop the solution that could enable these screening programs, because without AI, it simply is not possible. AI is going to help save time and help you fill out the very detailed reporting that is required for these lung cancer screening programs. So what does our solution then offer? Well, it starts with detection of nodules, classification of the types of nodules, measurements, but also volume doubling time calculations. So what we do is we automatically fetch prior scans and we measure the diameters and the volumes on the current and the prior scans so that radiologists can use that information to already advise potential follow-up according to the guidelines. There's no need to do any manual work for that. So based on the AI that is currently classified as a CE solution and can be used in both routine clinical practice but also in screening, we expect that radiologists will save significant time. And this is just anecdotal, but with one of our first customers in the UK, we actually did a timed read where one radiologist was reading the whole scan without any AI support or reporting tool. Took him 10 minutes to 15 minutes. With our solution, it actually reduced it to 5 minutes and it was completely reported according to the requirements. So we can show a very crucial time savings there. The solution has been developed based on all kinds of data sets. So we've used 45,000 data sets from multiple sources, but also developed on top of that our own annotations. So Lizzie actually helped organize, but also do some annotations on these data sets to make sure that it contains the high quality annotations for an algorithm that is accurate to report scans at human level, even surpassing that quality of human levels. The solution, we validated that on different data sets, and we actually received money from the NHS to fund the clinical study that was performed at the NHS Lothian and with the University of Edinburgh, where we validated our algorithm against 3 human radiologists to see and validate how accurate the solution was. And based on that study, we confirmed that the detection of nodules, as well as the detailed reporting about all the aspects of the nodules, was on par or even better than humans. Combining our AI together with human radiologists even surpassed that level. So bringing back together the human aspect and the AI will solve a time issue, but also a quality issue in reporting lung nodules. Solution has been developed using all kinds of security standards, but also medical device standards, and it complies with all the NHS data security toolkits. While we are developing this tool, we're also working, for example, with regulatory bodies to improve the standards to use AI solutions in clinical practice and in screening programs. So that's what AI can bring basically to lung cancer screening programs. And currently the solution is being used across several sites in Europe. Liverpool Heart and Chest in the UK was actually our first site, but we're live now since a couple of weeks also in Hull, where they are running a very active lung health check program, and we are in total running across more than 14 sites actually now in Europe, France, UK, the Netherlands, Greece, Hungary, where they're also doing a lung cancer screening program. And we're analyzing more than 1,000 CT chests on a weekly basis. That is both in routine clinical practice as well as in lung cancer screening programs.
Yep.
One of the sites where they're currently using our solution in clinical practice, we're also looking at opportunities to use this for potential lung cancer screening program, is the Northwest Clinics. They were one of our first customers here in the Netherlands. And I wanted to emphasize this site because they saw a clear problem. They set up an actual cardiovascular program where they had more inflow of patients, and the result of those patients coming into the hospital was that there were also more requests for nodule reports. So that's where they are using this solution now to report all the nodules according to a consistent required template, and follow up all the nodules at a higher pace than they could manually do. So this is in routine clinical practice, and we're emphasizing this case so that you can understand that it's not only relevant for screening. Lizzie, integration.
Yes, so we've talked about the AI aspect and the deep learning aspect of Veye Chest, which is, of course, all this exciting technology that's been talked about. There's been a lot of hype around AI, and it's now starting to be used in clinical practice. I think what I immediately loved about Aidance when I started working here is how important it is for Aidance to be fully integrated into the radiology workflow. And I think we have a really good understanding of that, and we work very closely with radiologists that we're working with to make sure that we make their life as easy as possible. The idea is we're trying to improve efficiency. Of course, we want to improve accuracy and that as well, but we're aware of this big burden of volume of workload, and that's what we're trying to help reduce. So VyeChest is fully integrated into PACS, and I think we've got some anecdotal evidence of what a game changer that is, how helpful that is, that radiologists don't have to log on to a specific workstation. It even enables flexible working, remote working. If they have the ability to report on a PACS from home, that means they also have the ability to use VyeChest because it's integrated in PACS. Of course, another thing is that it's fully automated. So I know with some of the older CAD systems that weren't widely adopted, one of the issues, as well as not being fully integrated, but was the fact that radiology departments, radiographers would have to plan ahead and upload images onto the system so it could be read by that software before they had results. None of that happens with VyeChest. It's all automated, so it works in the background, communicating directly with the PACS, and the results are there by the time the radiologist opens that scan to report it. And I think we really, yes, it's maybe the less exciting part of the software development and technology, doing all that integration into the already existing workflow, but I think that's really, really important and is what makes us
stand apart.
Yeah.
And it's the only way how you can actually save time.
Exactly. So as I said, I think we do have a quote here from Caroline, who's one of our radiologists we've worked with for a few years now from Liverpool Heart and Chest, and certainly she loves the fact that it's integrated in PACS. So Irene alluded to the other thing that we've developed, which so not only we've done the VyeChest and the detection of the nodules and the volume doubling time, what we've gone on to do is then develop this interactive reporting feature specifically for the targeted lung health checks in the NHS, because there was a real need for that. But the way we've developed it means that we will be able to adapt that to different countries. So as you also mentioned, we've got Greece, Hungary, there's lots of other countries discussing ways that they're going to do their screening, and they may use different guidelines. So we'll have the ability to actually adapt this reporting feature to make sure we fit their guidelines. So the purpose of it is that it means that the radiologist can comply with the standards that have been set out by the NHS pro forma. So one of the things is doing the Brock score to calculate risk of malignancy, which is quite time consuming, so that's automated. We also generate the BTS guidelines, what the recommended follow-up is, to make all these parts of the process a lot more efficient for the radiologist, rather than having to look up things and what they should be doing every time. Obviously, also there's the incidental findings, which there's a whole long list of, and we've tried to make that as easy, intuitive, simple as possible for the radiologist, so that it's quick for them to use. But it also complies with the standards, and then we've got this consistent report for all the lung cancer screening, lung health check, individual patients.
Yeah. So you touched upon learnings and that we developed this solution based on the input from radiologists, but we're already getting more and more requests. So the AI is impacting the reading. The speed is increased, so the time required to report these scans is significantly reduced. But all this information that now is being created by the AI also results in a data set that can be used, for example, to validate the program. So that lung health checks, what's the quality of the program, what are the outcomes? This is all being collected in the background because the AI feeds this information into a database that then radiologists are using to create reports. So we're getting questions about how can we use that data to manage patients. We now have patients that come in for a first scan that need a second scan in 3, 6 or 12 months. Can you develop a system to automatically follow up those patients so that we don't lose track of them? That's what we're already learning. That's what we're seeing after running in these programs for 2-3 months. Yep. So it's quite exciting to see that just with one application you're already seeing different needs arise that this technology can solve. So we can reduce the time to read, but we can also help making decisions on how to improve lung cancer screening programs, for example. And we can help them manage the quality of these programs. Potentially down the line, there are other opportunities where AI could help make decisions on what kind of treatments to apply, to stop certain treatments and change strategies. But this is further down the line. We're already seeing the need and moving to basically that area. So patient tracking is something that's on our radar, but like Lizzie mentioned as well, incidental findings. We've already started actually developing another solution, coronary artery calcification.
We have.
That is required for reporting a lung cancer screening, but also in routine clinical practice, this is an application that we've had questions about. So based on the input from screening, where we're now already having a big impact, we think we can increase the impact by developing more features around the solution. And we would love to get the input further from the market, from the radiologists, the users, but also the commissioners who are using this information and to pay for solutions like this. So we're closely collaborating with these organizations and people behind the scenes. So, to finalize.
Yeah, so some take-home messages. I think what we believe is really important for AI to play an effective role in lung cancer screening programs and how to help make those programs successful, feasible, sustainable, is to make sure, like I've said, can't emphasize it enough, that the software is fully integrated into the pre-existing workflow, so it doesn't disrupt that workflow that's there. And yes, we've worked so far on the radiologist sort of point of view, but you know, there's the wider pathway. There's also from GPs through to MDTs, physicians, oncologists, surgeons. We appreciate there's this whole wider pathway. Of course, the regulations. So there's we're keeping up to date, making sure we're always meet the regulatory frameworks and standards, and all of this is still being developed for AI as it's quite a new area, and we're closely involved in helping develop some of those guidelines because we have experience from working in clinical practice so far. The automation side of it, it's about automating the things that can be automated, making things quicker for radiologists. So there's the speed, as we've talked about, the efficiency, but then there's also the accuracy. In particular with early lung cancer, it can be really subtle, and actually a computer can be really, really good at detecting subtle changes and abnormalities that perhaps sometimes a radiologist, especially a very overworked, radiologist with external pressures and stresses, perhaps having that second pair of eyes from Veye will help make sure that things aren't missed. And then finally, collaboration. So again, I think what I love about this company, and I think what makes people like working with us, is how much we want to collaborate with radiologists, with physicians, with how much we want to understand what the unmet needs are and how we can help. We can start developing these technologies, but if it's not needed, there's sort of no point to it. So it's about defining what's an unmet need and how we can improve that. We can develop very sexy technology, but if it's not useful, it's not going to be adopted. So exactly, we're basically working every day with radiologists to provide the solutions that they need. Exactly. Okay. So with that, we come to the end of this presentation and the end of our live series today. We thank you for participating. Thank you for watching. If you have any questions, don't hesitate to reach out. And we'll see you soon, either at a live event or again during some live streaming. Thank you for watching. Thank you.